055, Mayday, Mayday, Mayday.
Hello guys, today I will try to explain the turbine clearance control system in gas turbine engines under the title of engine air. Before moving on to my explanation, it is worth noting this. Aircraft air systems and engine air systems are separate systems. However, in general, the main source of aircraft air systems is the engine itself. In this lesson, we will see the functions, parts, and working principles of the turbine clearance system. The importance of air in the lives of living things is an indisputable fact. This reality also applies to aircrafts and their turbine engines. The efficient and healthy operation of many systems in the engine is made possible by the energy taken from the air. In addition to contributing directly to the operation of the engine, air also plays important roles in the operation of some subsystems. The first system we will examine under the heading of engine air is the turbine clearance control system. The main purpose of this system is to ensure that the distance between the rotating and non-rotating parts of the turbine parts of the engine is kept at a minimum level under all operating conditions of the engine. This task is so difficult that it requires processing many parameters within seconds to achieve it. The slightest systemic malfunction can cause serious damage to the engine. Thanks to the correct operation of this system, maximum efficiency is achieved from the turbine where kinetic energy is obtained. Before we start explaining our topic, let's try to remember our past engine information. The task of the turbine section is to convert the hot gases coming out of the combustion chamber, or rather the chemical energy, into motion energy. The motion energy received from the turbine is used in important and vital tasks such as rotating the engine compressor, cooling the engine, and moving the gearboxes. At this point, how much of the energy the turbine receives from the burned gases is converted into work, that is, motion energy, is expressed as turbine efficiency. In other words, the more efficiently the turbine operates, the higher performance the engine compressor will absorb air from the atmosphere. In parallel, all mechanical units are powered by gearboxes will be able to fulfill their duties with full performance. Additionally, engine cooling be sufficient. What we refer to as turbine efficiency here is actually related to how little burnt gases pass between the turbine blades and the turbine case. To achieve this, the turbine clearance system keeps the distance between the turbine case and blade tip under control. Because controlling this distance not only increases the turbine efficiency but also prevents the blades, which extend due to centrifugal and temperature effects, from rubbing against the case. The acceptable rate of burnt gases passing through the gap between the blades and the case means that most of the energy is used in the turbine rotor. Hot gases that do not do any work passing between the blade and the case are described as loss and leakage. However, it is a fact that lost and leaked gases will pass through this point to a greater or lesser extent. But keeping this to a minimum is necessary for turbine efficiency. The turbine clearance system controls only the case section in the turbine section. Let's take a look at how the turbine clearance system works on CFM56 engines. During engine operation, the operation of the turbine clearance system is managed by an electronic engine control called EC, which we can refer to as artificial intelligence. The turbine clearance control system ensures that the gaps between the cases of the high-pressure turbine and low-pressure turbine blades are generally kept to a minimum. The purpose here is to prevent the blade tips of the high-pressure turbine and low-pressure turbine from extending and rubbing against the case due to centrifugal effects due to high temperature and high-speed rotation. Thanks to this, the heat energy produced in the engine is converted into motion energy at the maximum rate and fuel efficiency is increased. EC uses the hydromechanical unit, valves and actuators to adjust the clearance between the blades and cases of the high-pressure turbine and the low-pressure turbine. EC also prevents the risk of a possible stall by controlling the airflow in the compressor. The EEC operates the air valves and actuators via the hydromechanical unit. EC sends digital informations to HMU about what to do in the light of the information it receives from aircraft's sensor. HMU, on the other hand, moves the valves and actuators mechanically by sending servo fuel pressure to the units. Turbine clearance system can increase the gap between the high-pressured turbine blades and the case special conditions, that is, in malfunction situations where the engine internal temperature varies or when the engine is given high power. The clearance system works automatically, independent of the pilot. Hot compressor air sent into the turbine case through the valves in the system heats or cools the case. Heating the case increases or decreases the gap between the rotor blade tips and the case. In fact, the turbine clearance system uses basic physics laws during this process. In other words, the expansion of the case is achieved with the hot air sent into the case. As a result of this process, in addition to increasing the turbine efficiency, the elongation of the blades due to centrifugal effects and temperature effects and the possibility of rubbing against the case are prevented. While performing these tasks, the turbine clearance system uses low-pressure turbine active clearance control and high-pressure turbine active clearance control systems. Now let's get to know these systems. The high-pressure turbine active clearance control system consists of a valve manifolds and a bleed air duct located in the 9th stage of the high-pressure compressor. The high-pressure turbine active clearance control valve is mounted on the upper right side of the engine high-pressure compressor case. The function of this valve is to mix the 4th and 9th stage high-pressure compressor air and control its goes to the high-pressure turbine case in the appropriate amount and temperature. The function of high-pressure turbine active clearance control manifolds is to ensure that the hot air taken from the compressor is carried to the turbine. In order for the high-pressure turbine active clearance control system to operate, the electronic engine control needs the following datas: ambient pressure, N2 compressor speed, compressor discharge air temperature. From these data, the ambient pressure is taken from the DEU display electronic unit and other data is taken from the engine systems. There is air pressure in the compressor stages as long as the engine is running. When the high-pressure turbine active clearance control valve is opened, the compressor air enters the high-pressure turbine case from the 6 and 12 o'clock directions through the manifolds. EC high-pressure turbine uses HMU to mechanically control the position of the active clearance control valve. HMU sends fuel pressure to the servo to move the high-pressure turbine active clearance control valve actuator. The high-pressure turbine active clearance control actuator sends the appropriate amount of air from the valve to the turbine case with the movement it receives. The high-pressure turbine active clearance control actuator also maintains coordinated operation by sending digital position data to the EEC. The low-pressure turbine active clearance control system works similarly to the high-pressure turbine active clearance control system. The difference of the low-pressure turbine active clearance control system is that it uses fan discharge air and cools the low-pressure turbine case section. Low-pressure turbine active clearance control system consists of 3 parts: valve, air duct, and manifold. The system valve is mounted in the lower right part of the low-pressure compressor case. Low-pressure turbine active clearance control system controls the amount of fan discharge air going to the low-pressure turbine case through a valve. In this way, the clearance between the low-pressure turbine blade tip and the case is controlled. Cooling the low-pressure turbine case controls thermal expansion, keeping the clearance with the low-pressure turbine blade tips encased to a minimum. This increases fuel and turbine efficiency. The low-pressure turbine active clearance control system operates automatically. The EEC uses data from the aircraft display electronics unit and the engine via to control the amount of fan sent air to the low-pressure turbine case. EC uses the following data to control the positions of the low-pressure turbine butterfly valve: total air pressure, ambient pressure, total air temperature, N1 compressor speed, exhaust gas temperature. The system valve is controlled by EEC and HMU as in the operation of the other system. Butterfly valve position information is constantly sent from the valve to channel A and channel B of the EEC. Correct and reliable operation of the system depends on EEC receiving correct information. So far, I have tried to explain the turbine clearance system in a simple and understandable way under the heading of engine air. Correct, reliable and precise operation of this system is very important in preventing serious malfunctions in the engine. Because improper operation of the system may cause a series of malfunctions that may damage critical parts in the engine and eventually cause the engine to stop. This situation may endanger flight safety and put the pilot in a difficult situation. As can be understood from the explanation, the turbine clearance system must work in a coordinated manner with other aircraft systems. For this reason, it is vital that all sensors on the aircraft are well maintained and clean. For this reason, especially pilots and aircraft technicians being careful about these issues will be beneficial in preventing possible malfunctions. At the end of this video, I prepared a test with 10 questions. You can understand whether you understand the subject by answering these questions. Goodbye, hope to see you in new videos.